So, talk about functions today.
Yay!
Right? So, formal definition of a function relates each element of a set with exactly one element of another set. So what that means is every x value should have exactly one y value that it comes out to if we're going to declare it a function. So if I plug 2 in for x into a function, I should only get one y value out of it. I shouldn't be able to get both 3 and 4 when I plug in 2. Right? That would make it not a function then. So like I said, it relates one input to an output. If we look at a function, we have a function name. Our input is always right next to that function name. And then we have what to output, or how we find our output on the other side of our equal sign. So if you look at this diagram here, this is a function because everything in that x value, in that x bubble, relates to exactly one element in the y set. Now, these two x's both relate to the same y. That's perfectly okay. That's like saying 2 squared is 4 and negative 2 squared is 4, right? Two different x's that make the same y. That is perfectly okay. Now, down here, however, this is not a function. If you look, one of our x values, 5, maps to both all the 4, 5, and 7. That's like saying I can plug 5 into a certain equation, and I can get 4, 5, or 7 for an answer. We can't have that, right? That's not a function then. So everything in 1, in your first one, maps to exactly one element in y. They map to the same element. They can't map to more than one element. Does that make sense? Maps to exactly one. So, where is our vertical line test? Down here. All right. The vertical line test. That's how we test these functions on a graph. So vertical line test is exactly what it sounds like. You draw a vertical line on the graph, and if it hits more than once, you know it's not a function. We're mapping to see, is every x value, right? This is an x value. Vertical line is written x equals something, correct? If it hits once, that means it has one y value. That's perfect. That means it's a function. If it hits more than once, it hits twice, 3 times, 4 times, any amount, it means it's not a function because it doesn't map to just one element of our y's. It maps to more than one. Right? So vertical line test, you draw in vertical lines. If it hits more than once, it would not be a function. All right? Does that make sense? Yes? No? You good? What's going on? Alrighty then. Do we have any questions before I move on?
No, just kind of came out.
Okay. Evaluating linear functions. This should be your review. You should be able to do this in your sleep. Right? If I give you a function f of x equals 2x plus 5, I ask you to find f of 3, what are you going to do? Plug 3 in for x. Right? You should have done this a million times already. So 2 times 3 plus 5. 2 times 3 is 6 plus 5 gives me 11. Right? If I give you f of x equals negative 6x minus 4, I ask you to find f of 1/2. What are you going to do? Plug 1/2 in for x. Negative 6 times 1/2 minus 4. Negative 6 times 1/2, or negative 6 divided by 2, is negative 3. Minus 4 gives me negative 7. The next one's a little trickier. G of x equals 2/3 x plus 10. Find x when g of x equals 70. How are you going to solve this one? Set it, 70 equals 2/3 x plus 10. Set it equal to it, right? If g of x equals 70, I should be able to replace that with 70. So 70 equals 2/3 x plus 10. And then solve it. Subtract 10. 60 equals 2/3 x. And remember, can I divide by a fraction? No, so I Multiply by the reciprocal. Very good. So times 3 halves. 3 halves times 60 will give us 90. Equal to x.
Wait, why can't you do 2/3 times 70 plus times?
Because that would be saying that x equals 70. We want to know when our function equals 70.
Wait, what?
So this is telling me f of 1/2. That's telling me x equals 1/2.
Okay.
I'm plugging that in. Here I'm finding x when my function equals 70. So I'm not saying that it's g of 70, because then I would plug 70 in for x. I'm saying the whole function, the whole g of x, is equal to 70.
Okay.
So I'm setting 70 equal to what my function equals.
Okay.
Okay? G of x, guys, and f of x, that's fancy ways to write y. Right? Normally we have like y equals our equation. A function is noted f of x, but it means the same as like y equals whatever, or g of x, same as y equals whatever. So if it helps you to think of it that way, think that as like y equals 70 and y equals 2/3 x plus 10. Alright? Okay. Linear graphs. How many of you can find f of 2? And? What do you think? We're not going to find the slope of a line, actually. First time all unit we haven't found the slope, right? Caitlin?
You find where x equals 2 on the graph.
Perfect, right? Normally if I have f of 2, we said we were going to plug 2 in for x, right? So I'm going to look, where does x equal 2? I want to know the y value at that point. That's my answer. Right? So if I look on here where x equals 2, and I look along x equals 2, where does that hit my graph? Well, it's right here. What's my y value? 0. So f of 2 equals 0. And you know, you can check it. If they gave you the function, you can plug 2 in, check it. They don't in this case. Like f of -1, same thing. Where x equals -1, what does y equal? Well, at -1 I look, where does it cross my graph? Down here, what's y value there? -6. Ooh, now we're going to flip it around. Find x when f of x equals 6. Guys, just like I said before, f of x is a fancy way of noting, like, y equals 6. Right? It's a function notation. Instead of having it like with y's in it, just noting it as a function. So if you want to rewrite it, say, hey, that means y equals 6. Do it. So y equals 6, I want to find x. So now I'm going to look and see, where does y equal 6? See, where does it cross my graph? What's my x value there? 5. So x equals 5 when the function equals 6. Okay? Does that make sense? Yes?
Yeah.
No? I have a question. This is what happens when you have a question. You put your hand up like this, and I'll answer it. Do we have any questions? No, we're good? And looks like a half a question. Is that half a question or is that no question?
It's question 1.
So you're going to ask it? Good.
I found the slope, right, and I just did x equals 2x minus 4, because that's the slope. And then I plugged in all those numbers in.
Wait. You found the slope. Then you got what?
X equals 2x minus 4. Like, I just plugged in.
And then you put, so if you find the equation, then it would work. Yeah, so like I said, if they give you the equation of your function, you can plug all those in, that's perfectly fine. If you want to go through the trouble of finding the slope, finding the y-intercept, writing an equation, and then plugging it into that equation, you can do it, that's fine. It takes a little more work, but it should give you the same answer. Okay? Alright. Evaluating absolute value functions. Hey, we dealt with absolute value earlier this year. Who would have thought it would come up again? Oh, crazy. Right, so, if I have the absolute value of 2x minus 4, I want to find f of 3. I'm going to do the same thing I did before. Plug 3 in for x. Absolute value of 2 times 3 minus 4. Well, remember, when we have an absolute value, we can't take the absolute value unless it's one number in there. So let's do our operations first. 2 times 3 gives me 6. 6 minus 4 will give me 2. Now I have one number narrowed down in there. What's the absolute value of 2? 2. So my answer is going to be 2. Same thing for the next one. G of x equals negative absolute value of x plus 7. Find g of 2. Well, negative absolute value of 2 plus 7. So I'm taking 2, plugging it in for x. What's the absolute value of 2? 2 still. Now this negative travels with me. It was not inside of my absolute values. It's got to go with. So it becomes negative 2 plus 7, which is going to be 5. Okay? Does that make sense?
Yeah.
Okay. Last one like this. H of x equals absolute value of 3x minus 5. If h of x equals 16, what are the values of x? How do we do this one? Some people are talking very quietly. Sarah?
You said 16 equal to the absolute value of 3x minus 5.
Perfect. Set 16 equal to our function, right? Our function equals 16. It also equals absolute value of 3x minus 5. Set them equal to each other. Well, I'm going to solve for x. I'm going to add 5. 21 equals the absolute value of 3x. I'm actually bring it up here.
Oh, positive, negative.
What was that?
Positive, negative.
Positive and negative, right? To get rid of our absolute values so that we can keep solving, we're going to split it into 2. Right? Because 3x could equal both positive 21 or it could equal negative 21. And it doesn't matter because it's going to take the absolute value of it. So we got to split it to one positive side, one negative side. And then we can keep solving because now we don't have an absolute value there in our way. So divide by 3. 7 equals x. Or divide by 3. Negative 7 equals x. Very good. Any questions before we go into the graph part? Okay, sweet. Our graph is just like the one we did before. Just now it's got an absolute value in it, which means it doesn't go negative. It's fine, right? So our absolute value here, I'm doing the same exact thing I did before. G of 4. That means I want to know when x is 4, what does y equal? So when x is 4, y equals 2. When x is 0, what does y equal? Because I want g of 0. 2 again. Oh, this one's a little tricky. If g of x equals 6, what is x? In other words, if y equals 6, what is my x value?
It's the
What did you say?
8 and negative 4.
8 and negative 4. Right? Because if I look at 6, I hit it over here, and I hit it over here. At both spots. So I need to put both answers. Okay, well, is g of x going to be a function then?
Yes.
How many people think that g of x will be a function? How many people think g of x will not be a function? Let's try it again. Let's have everybody vote. So there's like half the class that didn't vote. How many people think that g of x will be a function? Okay. How many people think that g of x will not be a function? Hey Johnny, since you didn't vote, why don't you explain me your answer? What do you think?
I think it will.
You think it will? Why is that?
Actually, no, I think it won't because the line goes through the thing twice.
Because the line goes through the thing twice. Does anyone want to argue with Johnny?
Wait, what did you say?
Ooh, Renee, do you want to argue with Johnny?
Because it's vertical line test, not horizontal.
Very good. So we're talking about the vertical line test. We're testing for a function, right? Vertical lines go up and down. If I draw vertical lines in here, Do any of those vertical lines hit more than once? No. So that means yes, it is a function, right?
Mr. Reed, didn't you say there can't be two answers?
They're what?
There can't be two answers.
There can't be one x value that goes to two y's. We can have different x values, right? Like x equals 8 and x equals -4. They can both equal the same y. We can't have it the other way around.
Two y's equal x.
Exactly. Which would be, if I went on here, right, a vertical line is an x value. If I hit more than once, that means those y's are all answers. Does that make sense?
Yeah.
Okay. So yes, this one is a function. It passes the vertical line test. I'm trying to trick you. Draw that horizontal line on.
You did trick me this week.
Got him good.
What?
All right. Any questions so far? We got a little left to do. Let's keep chugging. So evaluating other functions. Hey guys, question for you. We've had like f of x, we've had like g of x, we've had like p of a. We're gonna have like h of x, things like that. Does the letter in front mean anything? No, right? It's just like a variable. Variables can be any sort of letter. This is just saying like the p function with respect to a. F of x is the f function with respect to x. It's a placeholder basically telling you what type of function we're using. And that's going to be important later on when we deal with like f of x and g of x in our composite functions unit. We're going to deal with multiple functions at the same time. Alright? But it's basically a variable, it's labeling it. A certain letter. So this one, p of a equals -4 to the 3a power. Find p of -1. Huh. How do I do that? Okay, let's see. If I wrote it like this, f of x equals -4 to the 3x power. Find f of -1. That's a d there. Can you do that? Yeah, you can do this. It's the same thing. Except a is our variable instead of x. And they're naming it the p function instead of the f function. It's the same thing, guys. Don't get tripped up because they use different letters. Alright? All this is saying is, instead of p of a, I want -1 to be where a is. So we're going to take -1, we're going to plug it in for a. Alright, so just because they're using a different variable, it looks different, it looks like something we haven't done before, but it means the same thing as this. They just wrote it out differently. Okay? So don't get freaked out by it. So what I'm going to do, like I just said, I'm going to take -1, I'm going to plug it in for a. So I get -4 to the 3 times -1 power, which is -4 to the -3rd power. We have a negative exponent. We can't do this. You could just plug it in your calculator. That's one way to do it. Or, and, what are you going to say?
Can you turn it into a positive 1/3?
I like where your head is at, but not necessarily that.
Don't you like flip the -4 and then it...
We can flip the -4 into the denominator and it becomes a +3, right? One of our exponent rules was, I can take anything in the numerator or even in the denominator, and I can flip the fraction and make it a positive exponent. So it become like -1/4 to the positive 3rd power. Instead of -4 to the -3rd power, I flip it, and it becomes a positive exponent. In which case this would become -1/64, right? Because we could cube both 1 and 4. That's my answer, -1/64. Now you could just in your calculator plug in -4 in parentheses to the -3rd power, hit math fraction, and it's going to pop out -1/64. That's fine as well, right? I don't expect you to use your exponent rules at all times. It'd be great if you did, because that means you remembered them from when we did it. But I'm not expecting that. Okay? Alright. Next one. If f of x equals 2 to the x power, what is f of 3? Oh, what am I going to do? What? 2 to the third power, right? Plug 3 in for x. 2 to the third, which is 8. 2 times 2 is 4, times 2 is 8. 8. What is f to the negative third power? 1/8, right? 2 to the negative third. If I flip it, I get 1/2 to the positive third. If I use my exponent rules, 1/2 to the third is going to give me 1/8. All right? Are we all on the same page so far? All right, let's sprint through the rest of this. If f of x equals 64, what is x?
6.
Huh?
8.
What do you, well, hold on. What am I going to do? Don't just show numbers at me.
You gotta set it equal to.
Set it equal to 2x, 2 to the x, right? 64 equals 2 to the x. Oh boy.
2 to the 6.
I have an exponent, that's my variable.
Longer.
Logs, let's go!
Wait, do you have to?
We gotta switch it to log form.
I just did 2 to the whatever.
Yes!
64. Like, is that allowed? Yeah.
You can do that too, that's fine. You can guess the check.
Is it gonna
Sir?
get like more advanced in the future that we will have to do logs?
Off the top of my head, no, but
Okay.
Wait, I'm so confused where the 2 came from.
from our original function, right? F of x equals 2 to the x. So it's
Oh, okay.
64.
Okay.
So then change it to log form log. Base 2 of 64 equals x. In which case, I believe we get 6 equals x.
Yep.
Correct. Yes, if you guess and check, that is perfectly fine. But I love logs so much I want to do logs
I don't
again.
like that.
Actually, I wouldn't mind that.
Do you have an older or new one? This one. If you have the log base button, I think it's math, and then it's the alpha math, it's actually the A on there. It'd be log base, and you can put whatever base you want. If you don't, you have to use a change of base formula.
You do like
Log 64 divided by log 2.
by log 2. Yes.
Okay.
I did it.
Got it? Okay. All right. One quick problem, so we don't have a ton of time left, but I want to make sure we get to it. We're talking about Bermuda grass. It's growing at the given function of 5.9x plus 3.25, where f of x is the total height. That might be important. After x days from an initial measurement. How tall is the grass after 3 days? Well, what did I say was my number of days? What variable? X. So I'm going to take 3, and I'm going to plug it in for x. 5.9 times 3 plus 3.25. Not 8. I said 5. Not 8. Punch in your calculators. Let me know what you get. How tall is our grass after 3 days? 20.95. Wonderful. Part B here. The term 3.25 in the function represents the height of the grass when it was initially measured. The sample is how many times as tall after 3 days?
6.4.
How do you figure that out?
Divided by 3.25.
Just divide anything?
You divide.
Divide how tall it is by what it started at, right? That'll give us how many times bigger it has gotten. So if we take what we have after 3 days, 20.95, and I divide by how tall it was to begin with, that'll tell me how many times bigger it has gotten. In this case, sir, what did you say it is?
6.45 times.
6.4. Good enough for me. Just going to try to rush through this. Part C, if the Bermuda grass is 50.45 inches tall, how many days has it been growing? And what are you going to do?
You're gonna set 50.45 equals
Yeah. F of x is the total height. So if I know the height is 50.45, I'm going to set it equal to my equation. 50.45 equals 5.9x plus 3.25. And then just solve that out. Subtract 3.25. we get 47.20 equals 5.9x. Divide by 5.9. You should get 8 equals x. And 8 is representing the what? Number of days. Very good. Awesome. Swipe up. Subscribe.
Still recording.